AI is promising some pretty incredible things, especially when it comes to understanding customers. But how do we know we can actually trust its insights? With so much on the line, we need a lot more than just blind faith in an algorithm. So today, we're going to break down a scientific framework for validating AI research to make sure its power is matched by its reliability.
So let's just get right to it. Can you really trust an AI to read your customer's mind? It's a massive promise, right? Getting instant insights without all the costly, slow surveys. But the risk is just as huge. I mean, bad data from a flawed AI can lead to some absolutely disastrous business decisions. The real question is, how do we separate the actual science from the science fiction?
All right, here's how we're going to tackle this. First, we'll ask the big question. Is AI research a source of trust or is it a trap? Then we're going to build our validation framework layer by layer. We'll start with the foundation, which is called the ground truth. Then we'll test for stability and reproducibility. And finally, we'll do the all-important reality check. And to finish, we'll wrap it all up with a super practical scientific rigor checklist. Look, AI models can be amazing. They really can. But they can also hallucinate or give you results that are biased or just unstable. The hype is real, for sure, but so are the risks. The key is to move beyond the hype and apply a really rigorous scientific framework. And that's how we turn a potential trap into a tool we can actually trust. So, where do we even begin building a tool like that? Well, like building a house, every reliable model has to start with a solid foundation. In the world of AI research, we call that foundation the ground truth. It all boils down to a simple idea. The quality of your insights is only as good as the quality of the data you feed the machine. Garbage in, garbage out.
So what exactly is ground truth? Well, it's the idea that you don't train an AI in some digital vacuum. You have to base its entire understanding of the world on high-quality, representative, real-world data. We're talking about information from solid literature reviews and actual data collection. It's all about starting with reality.
I love this analogy. Just think of your AI model like it's a living thing. To be healthy, it needs high-quality nutrients, which is just clean, representative data. If you feed it junk food, bad data, it's going to get sick. And that sickness shows up as the disease of biased and totally unreliable results. It's honestly that simple. So what does this look like in practice? Well, the goal is to make your input data a mirror image of real-world demographics. For example, if you want an AI to represent 30-year-old women, the data you feed it must reflect the actual proportions you'd find for that group in things like census data. This isn't about guessing. It's about being precise. Okay, so once we have that solid foundation of ground truth, that's layer 1 done. Now we can move on to layer 2, stability. See, a trustworthy model isn't just right once in a while. It has to be consistently right. And this is where we stress test the model, just like a scientist in a lab, to make sure its results are reproducible. And this all comes from a core principle of science you probably remember from school: reproducibility. An experiment is only considered valid if you can run it again under the exact same conditions and get basically the same results. If the outcome is different every single time, well, then your findings are pretty much meaningless. So how do we do this with an AI? We run something called a stability stress test. It's a really straightforward 3-step process. First, you create one single clear prompt. Second, you run that exact same prompt with your model, let's say 50 times. And third, you gather up all 50 of those responses and analyze them to see how much they vary. And here's what you're looking for. If you see high variance where the answers are just scattered all over the map, that's a huge red flag. That's an unstable, unreliable model. But on the other hand, if you see low variance where all the responses are tightly clustered together, converging on a similar answer, that's the good stuff. That's the sign of a stable, reliable model. All right, we've got good data and we know our model is stable. Now we've reached the third and final layer, the reality check. This is the ultimate test. This is where we take the AI's output and put it head-to-head with real human responses to see if its predictions actually line up with the real world. Now, the fancy scientific term for this is cross-validation, or sometimes triangulation, but it's a pretty powerful and simple idea. You're just using multiple tools, in our case, an AI and a human survey, to study the exact same question. And if the results from both methods point in the same direction, boom, your confidence in the answer just skyrockets. Let's make this really tangible. Imagine you survey 100 real people about a new product, and their average purchase intent score is a 7.8 out of 10.
Then you turn around, ask your validated AI avatar the same exact question, and it predicts a score of 7.9. Wow, that is an incredibly close alignment, and it's a powerful signal that your model is accurate. But, how close is close enough? Well, in data science, we actually have a number for that. We measure this alignment using a metric called the Pearson correlation. And the magic number, the gold standard you're looking for, is a score greater than 0.85. If you can hit that, you've got a very strong, highly predictive, and scientifically valid model. So, now that we've gone through our 3 critical layers of validation, it's time to bring it all together. This last section is the scientific rigor checklist. It's the complete blueprint that pulls everything we've just talked about into one single, actionable framework. This is it. This is the blueprint for building trust. It's how we move AI research from being some mysterious black box to a transparent process that's grounded in real, established scientific methods. So this checklist basically lays out the whole game plan. For every step in your research, there's a specific scientific tool to make sure it's valid. For your data input, you use stratified sampling to eliminate those weird AI hallucinations. For prompt testing, you use control groups to make sure your questions aren't biased. In your response analysis, you run a consistency test using a p-value to ensure your result wasn't just pure luck. And finally, for the conclusion, you use criterion validation to prove the AI actually reflects the real world. That's the whole shebang. So why does all of this matter? Because when we start talking about things like stratified sampling and Pearson correlation, we elevate the entire conversation. This isn't just about cool ChatGPT tips anymore. This is data science. And this framework gives leaders, CEOs, CMOs, a real process to evaluate and invest in serious professional-grade AI tools. And that leaves us with one final and pretty exciting question. We now know that AI research can be scientifically validated. We can make it trustworthy. So, with that barrier gone, what's the next huge, difficult question about human behavior that we can finally actually answer?